Hello, hola, bonjour. My name is Prasanna Solanki. Welcome to my presentation. The topic is how to optimize cloud resource provisioning cost using quantum genetic algorithm.
Now, let us understand the problem first. In cloud computing, cloud providers can offer cloud consumers two provisioning plans for computing resources, namely reservation and on-demand plans. In general, cost of utilizing computing resources provisioned by reservation plan is cheaper than that provisioned by on-demand plan, since cloud consumer has to pay to provider in advance. With the reservation plan, the consumer can reduce the total resource provisioning cost. However, the best advanced reservation of resources is difficult to be achieved due to uncertainty of consumers' future demands and providers' resource prices. The solution of this optimization problem lies under the hood of quantum computing. The proposed solution has two important components. One is qubits and second is superposition. Unlike the classical bits, a quantum bit or a qubit can be 0 and 1 at the same time. Thus, multiple states can be achieved simultaneously. To understand the superposition phenomena in context with our optimization problem, consider an example of a maze. Now, multiple combinations are possible to optimize the cost. Thus, there are so many possibilities to get the desired combination of events. Using the superposition phenomena, a quantum computer can check all the possibilities simultaneously to find the desired optimum way to reduce the resource provisioning cost. To find out the most optimum solution is a NP-hard problem, same as there are multiple ways to get out of the maze. As a solution, the quantum genetic algorithm has been proposed, as it has been used to resolve many optimization problems in previous research works. In this algorithm, the string of data is termed as chromosome, which is smallest unit of given dataset. The first step consists of the initialization of quantum population Q of 0 of chromosomes. P of 0 is a set of measurements of each chromosome. T is level of generation, so T plus 1 naturally is a next generation obtained after fitness evaluation. Next step is updating population by applying quantum gates such as rotation gate and mutation gate. We obtain a population P of T composed of classical chromosomes or bit strings. Final step is the measurement. This algorithm will correspond to quantum circuit shown in this slide from left to right, a quantum register, input state psi of 0, information processing step U of t, and the output as a result of measuring or observing the state of each qubit. In intermediate stage, fitness gate will be used for updating the population of chromosomes, and Grover's search gate will be used to search the fittest chromosome. Now moving towards methodology. This is an experimental setup considering the scenarios required to generate data by using simulators. There are three provisioning phases: reservation, expanding, and on-demand phase. As shown, these phases with their actions performed in different points of time. First, in the reservation phase, without knowing the consumer's actual demand, the cloud broker provisions resources with reservation plan in advance. In the expanding phase, the price and demand are realized and the reserved resources can be utilized. As a result, the reserved resources could be observed to be either over-provisioned or under-provisioned. If the demand exceeds the amount of reserved resources, the broker can pay for additional resources with on-demand plan, and then the on-demand phase starts. Now this slide explains the research method processes. First one is obviously procuring the data. Three ways to do it: dummy data, scraping online data, and generating data using grid simulations. Out of these, one will be chosen. Second is structuring the data. After that, representing the structured data in quantum format. The fourth process is encoding chromosomes on qubits. There are two ways to do it. One is using quantum genetic algorithm technique and other one is by using autoencoders. The fifth process will be applying the quantum gates, and sixth and important stage is simulations. Two ways to carry out some simulations. One is quantum programming and second one is using quantum circuit GUIs. The seventh stage is evaluating the probabilistic output obtained from sixth stage. The final stage is comparing results with resource provisioning cost incurred without using quantum genetic algorithm. Concluding remarks. The aim of this proposal is to explore the possibility of resolving cloud resource provisioning cost optimization problem using quantum computing, as optimization problems have been addressed earlier using quantum genetic algorithm. The proposed solution is practical and feasible. I am open for questions on the given email address. Thank you for your attention.